Hi ladies and gentlemen, in the last video we said about a 4:1 multiplexer. We saw the design, we implemented it in QUCS and Verilog. So today we see an enhanced version of it. That's an 8:1 multiplexer wherein I have 8 inputs, 8 data inputs and 3 select lines, log a to the base 2, 3 select lines and 1 output line. So we will see the simulation in QUCS and we will see how this is implemented using the 74151 IC. So let me start with that presentation. So the speech is organized into your learning outcomes, then 8:1 multiplexer and its implementation using QUCS, then 8:1 mux using ICs, that is 74151 IC, and summary of your learning outcomes. So what you will learn in this video, or you will learn to and realize 8:1 multiplexer using basic gates, and they will you will implement it in QUCS. Then you will appreciate the wiring diagram of IC 74151, which is an 8:1 mux. So let us consider an 8:1 multiplexer. This has got 8 input lines. They are from I0, I1, I2 to say I7. There are 8 inputs are there. These are all 5 input AND gates. This is an AND OR configuration with 5 input AND gates and 1 OR gate. So 3 inputs of each gate, they go to the min time, like S0 bar, S1 bar, S2 bar, that way. S2 bar, S1 bar, S0 bar. Here it is S2 bar, S0 bar, S1, S0 bar, that way. So I have all the min times M0 to M7 happening here. So they go to different AND gates. And then there is a common enable signal to given to all AND gates. Only if this enable is high, then this circuit will work. So this is the AND OR configuration. So when S3, S2, this is S2, S1, S0. When it is 0, 0, 0, I0 comes out. When it is 0, 0, 1, I1 comes out. When it is 1, 1, 1, I7 comes out. That is a configuration. That's how this works. Now this circuit can be simulated in QUCS like this. So this is a circuit in QUCS. So this is a straightforward implementation. Here these are all 5 input AND gates, and this is a 8 input OR gate, and there are 2, 3 select lines, S2, S1, S0, S2, S1, S0. These are, and S2 bar, S0, S1 bar, and S0 bar. So 8 signals are given here. 8 signals are given here. Now I can perform the simulation and observe these outputs. This is Y is the output. These are I0 to I7. These are different signals, and when it is 0, 0, 0, I0 comes out. I0 is a 0. When it is 0, 0, 1, I1, again it is a 0. And when it is say 0, 1, 0, 0, 1, 0, 0, 0, 1, 1. When the inputs are 0, 1, 1, that is a 3. I3 should come out. I3 is a 1 that comes out. And here it is I4, 0, 1, 0, 0. It is I4. So I4 here is a 1, so that 1 comes out. Here this is 1, 0, 1, that is 6. That is 5. Sorry. Then I5 should come out. I5 is a 0 that comes out. The waveforms are given here. That is, this is S2, this is S1, this is S0. This is give a regular pattern from 0, 0, 0 to 1, 1, 1. So here you can try various examples. 0, 0, 0, I0 comes out. I0 is a 0. That is my Y. And if I come here, say here, this 0, 1, 1. 0, 1, 1 is a 3. So I3 should come out. I3 is a high. So that is why the output is high here. Or if I come here, this is my output is high here. If I come here, what is this? This is a 1, 1, 0. The S3, S2, S1, S0 is a 1, 1, 0. So that's a 6. So I6 should be 1. I6 is here. This is my I6. This is a 1. So that's why my output Y is a 1. So I0 to I7 lines come at the output depending on the select lines. Value of the select lines S2, S1, S0. So this is how I do the simulation of an 8:1 multiplexer in QUCS. So let me go back to my presentation. So then 8:1 mux can be implemented in the lab using an IC, that's a 74151 IC. So that's a monolithic 8:1 multiplexer. This you can test on the circuit like this. So this is a wiring diagram of the 74151 8:1 multiplexer. Here it has got 8 data inputs. These are D0, D1, D2, D3. That is pins 3, 4, 3, 2, 1. Then I have D4 here, D4, D5, D6, D7. These are the 8 data input, and these are the 3 select lines, S0, S1, S2. Here they have 11, 10 and 9. And the output, one output is at 5. This is a normal output, and this 6 is a complemented output. This 7 is connected to logic 0. This is an enable. This is a kind of a strobe signal or an enabled signal. Only if it is pulled to 0, then the circuit will work. And 16 is VCC and 8 is ground. So if I connect, if I place this chip on board and connect 8th pin to ground and 16th pin to VCC, and connect some data sources from at 1, 2, 3, 4, 5, 15, 14, 13 and 12. Some signals maybe with the toggle switches, say high low pattern, some non-pattern here, and if I apply S0, S1, S2 to 3 other toggle switches and apply different patterns, say 0, 0, 0 to 1, 1, 1, you can observe I0 through I7 values at the output 5. And this is tested by an LED that is connected in the normally on configuration. That is, when the pin 5 goes low, this LED glows, and when the pin 5 goes high, this LED stops glowing. Okay. So this is how you develop you set up an 8:1 multiplexer in the lab with the 74151 IC. Now coming to the end of the session, what you understood in this is you learned the 8:1 multiplexer using basic gates. Then you learn to simulate it in QUCS. Then you learn to implement 8:1 mux using the 74151 IC. And that is the end of this presentation. I thank you all.